Okay, welcome back. We're going to be looking again at complex numbers and again at the polar form. So now we're going to look at how the polar form can be useful instead of just how to calculate it. So we're going to be multiplying and dividing complex numbers in the polar form and see that it's actually quite easy, okay? So if we have a complex number in the polar form, we'll say it's z1 is equal to or1, which is going to be some number, multiplied by cos θ1 plus I sine θ1, okay, where θ1 and θ1 here, they're just an angle, okay, an angle in radians. So we have a number here that denotes the length, and then our angle here. And the same thing here, which is z2, we just have two different numbers. So they're saying we have two different complex numbers, okay? And the formulas here give us that if we multiply the two complex numbers, it's actually quite easy. We just have to multiply the two ors by each other, okay? So that's then multiplied, and then add the two angles, so θ1 plus θ2, and it's still in the polar form, it's still cos and still sine, but it's you just have to add the two numbers and multiply these two numbers, instead of, if we were to do this in the rectangular form, it'd be a bit messier, okay? And then dividing as well is quite handy. We're just going to divide or1 by or2, and then take θ1 or take θ2 away from θ1, so it's going to be θ1 minus θ2 in the brackets here, in the cos and the sine, okay? So we're going to look at an example here just to show it. I think I've used almost every single colour here. We'll use yellow. I haven't used yellow yet. Okay, so z1 multiplied by z2. So like the formula says, you're just going to multiply the two. So it's going to be equal to 3 multiplied by 4. Okay, so the two numbers. And then we're going to have, it's cos pi over 6 plus pi over 3 plus I sine pi over 6 plus pi over 3, okay? So I'm kind of writing up slanting there. So it's going to be equal to 12 multiplied by cos pi over 2 plus I sine pi over 2, okay? And then if they want us, say, to get this in the rectangular form, we can just stick this into our calculator, and we're going to get that that's equal to 0 plus 12i. Okay, that's just an example there of multiplying the two. So now I'm going to divide the two of them. So it should be the same kind of process. We're just going to follow the formula. So z1 divided by z2 is going to be equal to 3 divided by 4 multiplied by cos of pi over 6 minus pi over 3 plus I sine pi over 6 minus pi over 3. Stick this in a bracket. Okay, so I'm just going to leave this as equal to 3 over 4. Sorry, so is equal to 3 over 4 multiplied by, this is going to be the cos of minus pi over 6 plus I sine minus pi over 6. Okay, hope you can all still read that. And if you stick this into your calculator, basically you're going to get that 3 over 4, or sorry, no, get rid of that. I'm not going to have time to scribble that out, so I'm just going to work it out. It's going to be equal to 3, the square root of 3 over 8 minus 3 over 8 I. Okay, so like I said, this is going to work out if it's plus or minus. Just stick that on into the calculator and you'll find out that the imaginary value is minus and that this is plus. So this is only if they ask you to get it in the rectangular form. Otherwise this should be fine if they ask you to keep it in the polar form. Okay, hopefully that helped. It's just a quick video on the uses of the polar form, these two formulas here on multiplying and dividing numbers in the polar form.